Very good morning. So this is Dinakaran J, Assistant Professor working in the Department of Mechanical Engineering. Today I am going to discuss about the drone technologies subject. This subject comes under Regulation 2021 for a Department of Mechanical, Mechatronics and Robotics. So today we'll discuss the Unit 3 is drone flying and operation. Here the concept of operation for a drone. Drones, specifically quadcopters, work by generating a vertical lift through four high-speed motors and propellers that push air downward, overcoming gravity based on Newton's third law of motion. So they achieve a controlled flight by varying the rotation speeds of these propellers, allowing for altitude changes, pitching, rolling, and yawing. So, as we discuss here, before that, various terms, that is pitch, yaw, and roll. So, where the level of autonomy of drones based on the pitch, roll, and yaw. Pitch is forward and backward, and rolling is sideways, and yaw is rotation. So, you can see here the thrust, lift position through the propellers rotating. According to the Newton's third law of motion, it will lift by means of the drag force occurring, and then weight here. The weight, all the components are made inside the frame, so that the lift as well as the drag force occur. So normally the flying occurs in this manner. So they are the key principle of a drone flight is a lift and propulsion. So lift and propulsion based on the BLDC brushless DC motor spin propellers to create upward thrust. When all four propellers spin at the same speed, the drone hovers. And torque contraction, so to prevent the drone from spinning uncontrollably due to torque. Diagonally opposite propellers rotate in the same direction, while the other pairs rotates in the opposite direction. That is, one is two clockwise and the two other is anti-clockwise or counterclockwise direction. And maneuvering, as we discussed, the pitch, roll, and yaw. The rear motors of the speed up, while front motors slow down, or vice versa, to tilt the drone, the creating horizontal moment. So roll is sideways. The motors on one side spin faster than the other, causing the drone to tilt laterally position. So yaw is the rotation concept, a pair of diagonally opposite propeller which spins faster than the other pair, creating a net unbalanced torque that causes the drone to turn. So this concept, so the drone flight based on this uh, operations and principle, the drone flight will work. And core pillars of drone concept operation as a standard concepts operation inbuilt around the three critical elements. One is operational overview and risk identification and risk mitigation. So coming to the operational overview, the details, the mission goals. So such examples: cell tower inspection, packaging and delivery, the types of drones being used, and specific flight areas with the GPS coordinates. So here this risk identification spells out every potential hazards, including hardware failure, adverse weather concept, and or conflicts with other aircraft. Is the comes under risk identification, and mitigation explains how those hazards will be managed, such as using automatic return to home, that is RTH protocols for the lost links, or employing visual observers, that is VOs. So key operational categories: one is open, specific, and certified. So low risk flights, example hobbyist photography, that don't require a prior authorization as long as they follow standard safety rules, like staying under 400 feet is the open key operational categories. And specific categories: higher risk operations, example industrial inspection, that required a formal specific operation risk assessment, SORA, and authorization. Certified complex operation with the risk comparable to manned aviation, example large cargo delivery or urban air mobility. It's requiring full aircraft and pilot certifications. Coming to the flight modes, we have GPS mode, angle mode, and acro mode. So the drone flight modes are operational settings that determine the level of autopilot assistance versus manual control, which allowing drones to adapt to skill levels or tasks. They can have a key modes includes like GPS, stable, angle, self leaving, acro, manual, full aerobatic control. So altitude hold and return to home, specialized modes like follow me, sport, and waypoint allow for automated high speed or guided navigations. So these are the flight modes we have adopted in the drones, and the fundamental flight modes. These are the core modes built into most drones for basic operation. One is position mode, that is GPS position. Utilizes the compass and a sensor to maintain a fixed position as well as height or altitude, making it ideal for beginners. And self level mode is angle mode, uses a gyroscope and accelerometer to ensure the drone stays levels when control sticks are released. So it restricts the maximum tilt angle to prevent flippings. And acro mode is a manual mode or rate mode, which provides a full unrestricted control with no stabilization, allowing for advanced and acrobatic maneuvers. So which tends to the level of autonomy. Here the flight modes works. So continue with flight modes. The altitude hold mode maintains a consistent altitude using a barometer, allowing the pilot to focus on horizontal or directional control. And specialized and integration modes, we have sport mode. Sport mode maximizes speed and agility, often disabling obstacle avoidance. So follow me mode uses GPS or visual tracking to autonomously follow a subject. Return to home, RTH automatically returns the drones to its takeoff point based on battery or signal loss. Headless mode orients the drone's movement relative to a pilot position rather than the drone front, simplifying control. Waypoint navigation, which have executes the pre-programmed paths of uh, general, that is positioning sensor general positioning center, sensors, coordinates, and cinematic tripod mode slows down the movement and reduces the responsiveness for a smooth, precise footage, so that the cinematic record movement to reduce the responsiveness, which has in a flight modes conditions. A small drone in a controlled environment, we have particularly those under 250 grams like DJI Mini 4K or toy grade quadcopters are ideal for controlled environments such as indoor spaces, large warehouses, or netted areas. So these environments allows beginners to practice with features like headless mode, which is have a 360-degree flips and optical flow, which is minimizing the risk like mastering the flight. So next one is the key aspects of controlled environment flying, which is ideal location and recommended models, safety controls and benefits. So in the case of ideal location, the gymnasiums like a large door halls, or in if outdoors calm areas without wind or obstacle, which is in the ideal location, which is environment controlled flying. And recommended models, that is a DJI Mini 4K is a stable 4K graphite mini drones, beginners friendly. That is eco-friendly modes. We have these recommended models are Sunzita compact drone, and safety and control utilizes headless mode to eliminate orientation issues and take advantages of propeller guards for indoor safety. So benefits regarding the environmental control small drones is ideal for training, hobbyist fun, and developing piloting skills without needing. And we have regulatory permits for a small light and micro in many jurisdictions. Uh, Thank you for watching this video.